Hello everyone, so now we are going to learn ARP, Address Resolution Protocol. So we will do some basic 2 labs. So with that one we will have the idea what is ARP and how ARP is working, what is the function of the ARP. Because when you go for interview, they will start from the basic. They will ask you what is ARP. ARP is a broadcast packet or unicast packet, or how it is working, why we are using the ARP. In interview they will start. This is basic concept, but they are going to start from the basic. Whenever we are going for any interview, they will start first from the basic, then they will go for the advanced topic. So let's see here. First of all, what is ARP? I will take one computer here, one computer here. Now I have 2 computers. If you want, I will make little zoom. So this is my PC1, PC2 we can say. Why I am using packet tracer? In this one we can easily see the packets, we can study the packets. That's why I am using the packet tracer. Later we will do the other stuff in the EVNG or GNS3, no worries. And let me put some label here. I am putting some label for this machine and also for this machine. I am going to use the 2 IP address. We can use any IP address, but they should be in the same network as we are using the directly we are connecting. If you want to connect directly or if you want to use the switch, then they should be in the same network. How we can assign the IP? Just click and go in the desktop, assign the IP here. IP will be 192.168.1.1 and default subnet mask whatever is coming, I will keep that one only. Okay, and I will close this. And I will go here also. Let me assign the IP here also. I will write here 192.168.1.2. And here also whatever default subnet mask, I will keep that one also. So this one is good. Just we assign the IP address here. This machine is having IP. This machine is having the IP. So whenever we have the communication between 2 devices, they will send the ARP packet. So first of all, let me explain. See here. Example, this PC1 want to communicate with PC2. Okay, PC1 want to communicate with the PC2. They need to send some data here. So whenever they are sending the data, we have the Ethernet frame. In that one, what we will have? We will have the source IP. We will have the source IP and we will have the destination IP. Source IP, destination IP, like this. Let me erase in between this one, or let me draw a little big. Okay, whenever we are sending any frame from in Ether by using the Ethernet technology, we will have source IP. Okay, and we will have destination IP, then source MAC address and also destination MAC address. Whenever we are sending the Ethernet frame, we should have this information. Source IP, I am sitting here, I am sending some information to this guy. Okay, so this PC is called as a source because he is sending that one, and this machine is going to receive, so we are calling this one as a destination. So this machine is a destination and this machine is a source. So I should have this machine IP and I should have this machine IP. Whenever I am saying here ping 192.168.1.2, I have this IP. That's why I am pinging. So this source IP is my IP only. Okay, source IP is nothing but my machine IP only. This is the source IP, this is my IP. So this one no problem for me. I have that one. And I want to access or ping this one. So this is the destination IP. I have that one also. And source MAC address, this machine MAC address. So we have already, because from here only we are sending. I will show you MAC address also. So we have already the MAC address here. But destination MAC address, this guy MAC address we know, we don't know. This PC2 is a destination PC. We don't have this PC MAC address, right? We don't have this PC MAC address. So what we need to do? We need to get this PC MAC address and put in the frame, then only we can forward that one. Whenever we want to forward the Ethernet frame, we should have the source IP, we should have the destination IP, we should have the source MAC address, we should have the destination MAC address. This machine is having IP, that is source IP. This machine is having the MAC address, that is a source MAC address. and we are pinging the IP. That IP is a destination IP. We have that one, but we don't know the MAC address of this one, this machine MAC address. We don't know this guy. So to get the MAC address, we are sending ARP, Address Resolution Protocol. ARP is a protocol which are going to get the MAC address over the IP address. So what we will have, when we send the traffic, ARP will go here. ARP will go and he will say, hi, I am coming from 192.168.1.1 and my MAC address is whatever MAC you have here. Example, if you have AAA.AAA.A103. Example, this is the MAC address of this machine. So this our packet will say, hi, I am coming from 192.168.1.1. My MAC address is AAA.AAA.A103. I am looking the MAC address for 192.168.1.2. This packet will say, and this guy will reply and he will say, yes, I am the 192.168.1.2 and my MAC address is whatever he is having, that MAC address he is going to give that one. That will come here, that frame, and then after that he will put in the Ethernet frame. Source IP already we have, destination IP we have, source MAC address we have, destination MAC address we don't have, that's why we are waiting. Now we receive that one, he will put in here and then our ping packet will go here. Okay, this is a process. So let's see that one. How we can check? We can click this simulation. When we click this simulation, we can see the whatever packets are going here. So what I can do, I can open this one, I can go to the command prompt and I will put here if config, just to check the IP address I have or not. So I have already the IP address 192.168.1.1. So let me write here ping. Okay, and also there is one command also, ARP-A, to check the ARP entry. In our computer, we will check, do we have the ARP entry, that is MAC address related to IP address, do we have? By using this command, we can check ARP-A. If you check in real computer also, like this here, ARP-A, you can see I have lot of entry. What entry I have? This IP address is having this MAC address. How my machine know that one? He learn dynamically this machine, that this is my physical PC. He learn this IP is having this MAC address. So all they have, if you see this one also, they learn everything. Whatever IP I have, they learn that one. This IP is having this MAC address. This is dynamically they learn. This is a statically. So something configure this one, but this one they learn automatically. Okay, so this is a entry. Whenever I am sending any packet to any IP, they will put this example. This is a, what we can say, destination IP. This is a destination MAC. Maybe this is my router IP and this is the router interface MAC address. So they will forward to the router. After that, router will change the MAC address of the next destination and he will forward that one. Okay, so same thing here. I don't have any entry because still we did not communicate. That's why we don't have anything. So what I will do, I will communicate now. I will write here ping and then I will write 192.168.1.2, right? Our laptop, the other laptop is 1.2, this one. So I write here 1.2 and then when I press enter, if you see I have two packets. Okay, I have two frame here. If you see, this is a ICMP frame. This is a ICMP frame. OSI model, this is the, if you see here, this is a, or in simple, if you go and put your mouse here, this is ICMP, the ping packet. Whatever we are sending the ping, that is Internet Control Messaging Protocol, ICMP. Ping is nothing but ICMP. And also if you see, this is the ARP, Address Resolution Protocol. Because this computer, the PC1 is not having MAC address of the PC2, so he generate the ARP packet, Address Resolution Protocol. So how we can define the ARP? We can say Address Resolution Protocol is a protocol who is going to get the MAC address over the IP address. So he is going to check, he will say I need the MAC address of this IP, and he will get that one and he will bring and we will put in the ICMP packet and we will send that one. If we open the ARP packet here, if you see here what we have, the ARP packet, here we can study the ARP packet. If you see, this is a layer 2, okay, layer 2 packet we have, and if you see, this is a address, this is a FFFF dot FFFF dot FFFF. What is the meaning of this one? F is nothing but 255 dot 255 dot 255 means it is broadcasting. This is one of the interview question. We need to remember that one. ARP packet is a broadcast packet. Sometime they will ask you ARP is a broadcast or unicast or multicast. What ARP packet? So we need to say that one, that is a broadcast. How we can prove this way. It is broadcasting in the network. And you can see here ARP packet source IP we have here 192.168.1.1. Destination IP we have here 192.168.1.2, but we don't have the MAC address of the destination. Here also you can see this is the PC1, okay, add device, and this is the source. Destination we are doing the broadcast because we don't have that information. If you go outbound, this is the OSI model representation, and here outbound. So whatever is frame is leaving this machine, that is a outbound. So in outbound, what it is available in this packet, if we see here, we can make this big. Here this is the address, destination address. He don't know, right? He don't know to whom he should go and ask. Our packet don't know to go to server or to go to switch. Here I am using only one computer. Later we are going to see with the help of one switch we will have maybe 3 computers. So our packet don't know to go to this computer or go to another computer. That's why he is sending as a broadcast. So whatever machine we have in our network, that all guys are going to get this packet. Okay, and if you see this one, source address, okay, this is a source MAC address. And if you see here also, this is the ARP packet, okay, what we have inside the ARP packet, this one, source MAC address. And this is a source IP address. Destination MAC address, we don't know what is our destination MAC address. That is the PC2 MAC address, we don't know. So he is keeping 0.0.0. And target IP, target means destination machine. Target IP is 192.168.1.2, means this PC2 IP is a target IP. So he is saying source IP I have. Let me show you. Source IP we have, source MAC address we have, source IP we have, target MAC address we don't have, and target IP we have. If you want, you can go here, and we can go here. We will see here in the interface, this is a MAC address, okay, this is a MAC address. If you want to change, we can change in the packet tracer. In the real we will not change, because this is the burn-in address, that is interface is having the MAC address from the factory. So we will not change in the real scenario, but here in the packet tracer, if you want to change for lab purpose, we can change. So this is my MAC address. Let me put here. So we will see that. Okay, this is this PC1 MAC address is this one. And if you see here, this is the MAC address only. What we have here, this one, 000C.CF9B.036. Okay, so this is our machine MAC address. He is saying, because we are sending the data, so we are going to become as a source. And this is our MAC address, this is our IP address. Target we don't know anything, and target IP we know that one. Okay, and also if I go here, if I go to the physical or configure and then interface, this is the MAC address of the destination. Okay, let me copy and paste this MAC address here also. So we can cross check what it is going inside packet is correct or not. Okay, so now I will do this one. Okay, I will play this one. So packet will forward one step. So let me do this. ARP packet come here. Okay, this packet come here. This is a OSI model representation. This is the inbound. Inbound means before inbound means it is go inside. Outbound means it is coming back from this device. So what inbound is same whatever we saw here. It is having the source MAC address, it is having the source IP address, it is not having the target, that is destination MAC address, but it is having the target IP address, that is the destination IP address. But if you see outbound, it will become reverse, because this guy is going to send, right? Because if you see, this guy is going to send the packet, he is going to reply this about this packet. So this guy will become as a source and this guy will become as a destination. Let me show you. If I go outbound here, you can see here what we have. This is the source MAC address. This MAC address is for the PC2. If you see 001, this one, 00143B8.29EEE, this one. Okay, so this PC2 is replying to the PC1, so source is going to become this, PC2 become source, PC1 become as a destination. Okay, so if you see here, this is a PC2 IP and he is sending to the our MAC address, this one. He is giving his MAC address and his IP, and our MAC address already he learned, because when the packet first time ARP packet come here, he is saying that I am coming from here and this is my IP address, this is my MAC address. So this guy know that one, so that's why he's saying this is my MAC address, this is my IP, and I need to send to this MAC address and this IP. Okay, so now this packet will go back to the PC1. After that, PC1 is going to send the normal ICMP packet. He will accept that one, and now he is having the MAC address about this machine. He will put in the Ethernet frame and he will forward the ping packet. If you see, this is a normal ping packet, that is ICMP packet. If you see here, this is IP packet. It is having the source IP address, destination IP address. They are sending the ping. Okay, and going inside, coming outside, TTL value, whatever we have, this is ICMP packet. It is sending that one. And if I press this one, it will come back. We will have the 4 ping packet. It will go, it will come back. Okay, and if we go here in the desktop, here you will have the packets. 2 reply came. If I press here like this, one more, then we will have one more. And now if I see here, all 4 packets received. And now if I write this one, you will have the entry. Before we are getting no ARP entry, but now you will get that ARP entry. If you see, I have the ARP entry. What I have? We have internet address, that is IP address for 192.168.1.2, 192.168.1.2. This is a MAC address. How I learn? I learn dynamic, means no one configure statically, he learn himself. Okay, and if you want, you can cross check. This is the IP address for this machine and this is a MAC address. Here we learn how we learn dynamic. And if you go here also for the other PC also, you will have the same thing. You can write here ARP-A, and you can see other machine entries also there. This is the IP address, this machine, and this is the MAC address of that machine. How they learn? They learn dynamically. So this is a address resolution protocol. Okay, and here if you see, we will get the detail also, whatever they are sending here, the packets whatever they are sending, that time we can have the record. PC1 is sending, PC2 what packet they are sending, we can study. If you want to open, double click, it will open. Same thing what we discussed, that will be present here, this whatever they are sending. And now I need to go to the real time, so I will click this real time. So simulation will be closed. I am inside the real time now. So this is just ARP address resolution protocol, is a protocol which is going to get the MAC address over the IP address, and we need the MAC address whenever we want to send any information. We need our MAC address, our computer IP, and the destination MAC address and destination computer IP. That's all. Okay, this is the basic lab for the ARP with directly connected to PC. Now we are going to use the switch and we are going to learn the